Of course, if you're feeling depressed by that, you can always look at it the other way and think of how big you are compared to the atoms and the parts of atoms, and then you're an enormous universe to those atoms, so you can sort of stand in the middle and enjoy everything both ways. But the great part of astronomy is the imagination that's been necessary to guess what kinds of structures, what kinds of things can be happening to produce the light and the effects of the light and sort of the stars that we do see. And I could take an example, a historical example. See it many times in science. By using imagination, you've imagined something which could be, according to all the known knowledge of the laws, and you don't know whether it is yet or not. And that's very interesting. There's a creative imagination, you like to call it, not just imagining things that are relatively easy, but something different. And to take an example of a star, as we understand it, an ordinary star like the sun is a great big ball of gas, of hydrogen. It's burning up the hydrogen and so forth, and it's an enormous mass of gas. And it's held together by gravity. You don't have to always understand gravity as curved space. It's good enough for this purpose. Force inversely is square of the distance. When things are closer together, the force is stronger. And it pulls everything together. By the way, that's why the world is round. Because the globe of Earth is pulled together as much as possible. And if it had a great mountain and an irregularity of a bump, so it would be pulled in by gravity and it will get smooth. Rocks aren't strong enough to hold a bump much bigger than a few miles, and Mount Everest is our biggest bump. But on the moon, where the gravity's less, the bumps are higher, the mountains are bigger on the moon. Anyway, to get back to the star, it's all held together by gravity, and it's got a nuclear fuel, which we haven't been talking about